Thank you for coming here today. Good evening, everyone. It's me, Mr. Shah, and welcome to our Sec 4 EMATS lesson here at Geneva. It is a Thursday, 1st of December, 8:02 p.m. Thank you for coming here today. It's our first lesson of the new academic year. But I would like to inform you that I will actually not be the permanent teacher for this class. Okay, so I'm actually filling in for my fellow colleague and friend, Teacher Kim. She'll be your permanent teacher for this Sec 4E classes, for Sec 4E class on Thursdays. And she's very excited to meet you, but unfortunately she can't be here today, so I'm filling in for today. All right. Now, a quick show of hands before we start. How many of you have attended any of my lessons? I taught Sec 1 classes this year, and also a few Sec 2 classes at the start of the year. Anyone familiar with me and been to my lesson? Hi, Sherilyn. Yes, I remember you as well. Some of you here are a bit newer, don't really recognize your names, but hello. Hi, Denise. Hello, nice to see you here. Okay, without wasting any more time, I'm going to start. We have a very packed and exciting lesson up ahead. But before we do, just a few administrative things. We've got our Refer a Friend initiative here. You can actually look at the link that the moderator will be sending in the chat very shortly. Essentially, if you would like to refer someone who's not in Geniebook and you would like them to join Geniebook as well, if they do end up joining Geniebook, you can win up to 5,000 bubbles. Now, alternatively, apart from clicking the link, you could also actually just scan the QR code and access it after the lesson. Okay. Now, general rules: number one, be patient and understanding. Two, observe gracious and respectful behavior. And three, please feel free to ask me any good and relevant questions. Now, today we're going to start on a brand new topic and something that we've not quite covered before in Sec 1, 2, and 3, and that is set notation. Okay, it's actually a very, very fun lesson. For those of you who are more of a visual learner, you like looking at diagrams, you like, looking at things that are more visual as opposed to just numbers and algebra, I think you will find this a very, very fun topic. Okay, so we're going to start off by learning our terminology and symbols, followed by learning the different types of sets. So things like equal sets, empty set, universal set, and complement of a set. Now, it might sound like very, very new terms to all of you right now, but don't worry, by the end of the lesson, okay, the objective is for us to be familiarized with these different terms and the concepts behind them. Okay, now let's start with a very quick investigation over here. We're actually going to do a quick English lesson, not quite math just yet, but I want to ask you if you know what a group of lions are called or is called. When you have a group of lions, what do you call them? Anyone? Do you know? It's like, it starts with P. Very good, Perka, yes. It's a pride of lions. Okay, why is it called a pride of lions? I don't quite know, but maybe you can look that up. But moving on, what about fish? It's actually a school of fish. Okay, very good, Evan. Now, what about birds? I think this one's a bit more common compared to the rest. For birds, it's actually a flock of birds. Good. Now, a lot of you actually answered me and got that correct. Okay. Now, the idea, right, is that for animals, we use different words to actually describe a group of them: a pride of lions, a flock of birds, a school of fish. But for math, okay, when we have a collection of well-defined and distinct objects, things like numbers, alphabets, symbols, we can actually call them the term set. Okay. That's why this topic is called set notation. Now, the objects in a set, they are called elements. Okay, so things like I can have a set of numbers, okay, and each individual number in the set, they are called elements. All right, now a set can be denoted using capital letters, so big letters, unlike your algebra where you mostly use small letters. And the elements of a set are denoted using small letters. So elements are those numbers or terms inside of a set. Okay, the objects inside of a set, not terms. So let's go through some very simple set symbols. Now, if I want to describe the element P as being part of the set S, you notice that this is small p and this is capital S. Okay, I can use this symbol here. It looks like an E, all right, but it's written a bit differently. What about not an element of set S? So Q, not an element of set S. It's the same symbol, but similar to your not equal sign, right? There is a stroke, a forward stroke, like that. Okay, so this is what we mean by P is an element of S and Q is not an element of S. So what about the number of elements in set S? Instead of writing that statement down, which is very lengthy, you can just use this symbol, N bracket capital S. So what this means is N is the number of. The capital letter S refers to our set S. So therefore, if you read it together, it's the number of elements in set S. Okay, so with that, let's move on to the next slide. How can we describe a set? Okay, now there are three different ways. You might see them in different questions. Different questions may describe a set differently. Okay, firstly, you can describe a set using words. Now, this is very simple. All you need to do is to be able to read and comprehend what it means. So, S is the set of all single-digit even numbers. Now, alternatively, you can also list the elements in a set using set notation. So, S is the set, right? So I start with capital letter S. Now, one interesting thing or one defining thing about set notation is that we always use our curly brackets, curly braces. Okay? It's just a convention when we write down when we use set notation and we want to list down the elements in a set, okay, we will encompass the elements by using two curly braces. So, what are single digit even numbers? What is the smallest single digit even number? Is it 2 or is it 0? 2 or 0? Okay, I believe for this one, or single digit, oh, sorry, we should mention positive. Okay? No. Okay? So if I add the word positive there, right, it means that 0 is no longer counted. Okay, correct, Denise, very good. For 2, we start with 2, followed by 4, 6, and 8. After 8, the next even number is 10, so that's not counted. Okay, now we can also describe elements in a set using set notation. So for example, S equals to, I can write this as X. X is an element of the set S where X is a single digit positive even number. Okay, so there you go. Three different representations. S is a set of all single-digit positive even numbers. Okay, and from there, second row is just listing out the elements of this set. So 2, 4, 6, and 8. And last but not least, we can also use set notation to describe the elements of a set. And how I read this is basically saying S is the set where, sorry, X is an element of the set S. Sorry, you read this by starting here. X is an element of the set S where it is a single digit positive even number. Okay, now moving on. Okay, let's say that set S is a set of all single digit even numbers. Okay, now in this case, okay, hold on. Yeah, let me add the word positive in as well. Single digit positive even numbers. Okay, so sorry, because I add the word positive, right? I will be removing 0 from the set. Okay? Now, let me ask you a very simple question. Is 4 an element of set S? Okay? Given that there are four, I mean, the elements are 2, 4, 6, and 8, right? Very simple question. Is 4 an element of set S? Yes, definitely, right? So I can actually write this down as a statement or using the set symbols, okay, that 4 is indeed an element of set S. Okay, Dylan, if you missed the parts earlier where I introduced the set symbols, this symbol basically means is an element of. Okay, so there you go. You can actually just summarize it using this simple statement. Now, next question. Is 7 an element of set S? So if you look at the elements, 7 is not inside. So very simply, the answer is no. And we can also write down a statement. 7 is not an element of set S. Okay? And this symbol here basically means is not an element. Okay? So, what is the number of elements in set S? In this case, okay, how do we write it down using set notation? Number of elements can be written as n bracket, and inside we just write down the set, which is set S. What is the number of elements in set S in this case? Don't count 0, it's not included. Come on, what's the number of elements? 2, 4, 6, 8. So how many elements are there in total? Very good, Denise, 4. Okay, so there you go. Let's move on very quickly. Now that we know how to write our set notation and using the three set symbols that we have learned, is an element, is not an element, as well as number of elements in a set. Okay, let's answer let's try out this very simple example and see who can answer the questions. Okay, so in this case, A is a set of positive integers less than 30 that are divisible by 5. Now take note, less than 30, does it include 30? Less than 30, does it include 30? No, it excludes. Okay? Take note, it excludes 30. Okay? So let's first, and it's positive integers. Okay? So let's first start out by listing the elements in set A. So again, Dylan, I think you missed this part earlier. For set notation, we always represent the set with a capital letter, and we will encompass the elements of the set using our curly braces, curly parentheses. So in this case, what would be the first element of this set? A positive integer that is also divisible by 5. So what's the first element? We usually put it in ascending order from smallest to biggest. Anyone? What's the first element of set A? Denise, do you know? Okay, Raymond, Denise, very good, 5. Followed by multiples of 5, so 10. 10 can be divided by 5. 15 can be divided by 5. 20, 25, and then 30. But no, it excludes 30, so we actually remove that. We stop at 25. Okay, so there you go. How many elements do we have there? 5. Okay, now part B. Using set notation, describe whether each of the following numbers is an element of A or not. Now the first one, 12, is definitely not an element of A. So I can just say 12 is not an element of A. Second one, 23, also not an element of A. So 23 is not an element of A. Very straightforward. And last but not least, 10. 10 is present here, so it is an element of A. There you go. Very, very simple. Okay, now let's move on to bubble question 1. How many bubble questions do I have coming up? 2. Okay, so I've got 2 bubble questions coming up back to back. Just answer the questions. Just answer the question and choose the correct statement that answers the question. Okay, you'll get 1 minute for the first question because it's very, very simple. It's worth 10 bubbles, I think. Your time starts now. Yeah, it's worth 10 bubbles. Okay, let's go. Now, if you end, everyone can answer this question early. I mean, faster than the time that is given, then I'll just stop the question, stop the clock early. Okay, very good. I still have about 4 students left. 3 students now. Excellent. That was 20 seconds on the clock. You have about 35 seconds left. 2 more students, come on. Which of the above represents B in set notation? 1 more student left. Okay, 25 seconds on the clock. Come on, let's go. We're waiting. 15 seconds left. Now, who's the last student who hasn't answered? Can we get full response rate for this first question? No? 5, 4, 3, 2, and 1. Okay, I got 1 student who didn't manage to answer in time, but that's fine. Majority of you got this correct. That's great. Okay, we're off to a good start. Now, B is the set of positive integers less than 20. That means it doesn't include 20 and it's divisible by 4. Now, that means positive integers, once again, we want to start with 1, 2, 3, but 1, 2, 3 are not divisible by 4. So the first element is actually 4 itself, followed by 5, 6, 7 are not divisible by 4. So, sorry, the next one will be 8, and then it's just all the other multiples of 8, multiples of 4. So 4, 8, 12, 16, and then we don't include 20 because it excludes 20. It is less than 20. So there you go. 4, 8, 12, 16. Okay, very, very simple. There was a student who actually chose option 2, so you didn't include your 16 for that one. And I also had 1 student who chose option 3. So I want the set of positive integers. So not just 4, but everything from 4 to less than 20. Okay, so do take note. Now, let's move on to bubble question 2. Now, I'm still looking at set B, okay, positive integers that are less than 20 and divisible by 4. So in this case, I will just write down the set that we had earlier, that we wrote down earlier, 8, 12, 16. Now, which of the following statements is true? So you want to look at the 4 statements here and answer and choose the correct statement. Okay, 1 minute again for this, your time starts now. Very, very simple. Which of these statements are correct? So this is going to test you on the knowledge of how to read your set symbols correctly, the set notation correctly. Okay, make sure you by now understand what this symbol represents, and what this symbol represents. Okay, very, very important. Before we move on to more challenging concepts. Now, 30 seconds have passed. You have about 25 seconds left. Okay, I'll start counting down. Again, I've got 2 students left. Let's see if I can get a full response rate for this question. Yes, no? Oh, there you go. Everyone managed to answer on time, earlier than the time given. Okay, great work once again. Okay, we've got majority of you getting this correct. So which of the following statements is true? Let's go through one by one. Option 1 states that number of elements in set B is 3. So we know that to be wrong because there are 4. So immediately this is out. Option 2 states that 7 is an element of set B. Is that true? No. There's only 4, 8, 12, and 16. So option 2 is also wrong. Option 3 says that 8. 8 is an element of B, but this symbol here is not an element of B. So that's wrong because 8 is actually an element of B. Okay, so therefore we are left with option 4, which states that number of elements in set B is 4. So that's absolutely correct because we've got 1, 2, 3, 4 elements in set B. Okay, very, very easy first 2 questions to get us started. Now let's move on to our next math concept. So here we have 2 sets, okay, P and Q, and what are some conditions that have to be true in order to say that 2 sets P and Q are equal? Now, they must contain the exact same element. Okay, it must be exactly the same. Now, the order of the elements may be different. Okay, I mentioned earlier that generally, okay, we like to arrange our elements in ascending order, but that's not always the case. Sometimes it's all jumbled up, sometimes it's in descending order instead. So do take note. Okay, now exact same elements, this would actually be our first condition. But there is a second condition. What is the second condition? Second condition is that n bracket p is equal to n bracket q. Now, in other words, this means that the number of elements in both sets must also be the same. Okay? So two conditions, they must have the exact same elements, and the number of elements in both sets must be the same. Now, why is the second condition important? Because you can have two sets with the exact same elements, but maybe the second set has additional elements. Okay, so that's why it's also important to specify that the number of elements must be the same. Okay, so as I mentioned, if P is equal to Q, fill in the blanks with the missing elements. Now, I've got 3 in both sets. I have 6 in the first set, but I don't have 6 in the second set. I have 9 in both sets, and then I have 12 in the second set, and I don't have 12 in the first set. So for set P, what is the missing element? What is the missing element in set P? That means over here. I gave you a clue already, writing it in yellow. It's 12, very good. And then what's the missing element in set Q? 6. Okay, great, there you go. Now, I'm gonna move on to the next concept, which is on empty sets. Okay, so it's a lot of definitions, new definitions that we're learning. So just take some time to really understand and internalize it before we apply it into the questions, all right? Now, a set P is empty if it, I think it's quite self-explanatory, if it does not contain any element. Okay, so if you write this down in a notation, do you just write down P equals to 0? No. You need to actually show the two braces with nothing inside it. So it literally is an empty set. Now, there's an alternative way to present it, which is actually using another symbol, which is like a 0 or a circle with a forward stroke. Okay, now this symbol has also a special name, okay, which is null, the null symbol. Okay, so therefore, P can be called an empty set. It can also be called a null set. Oops, not a set. A null set. And they both mean the same thing. All right, so take note, both representations are fine to represent an empty set. Okay, so with that, I'm going to move on to work example 2. Now, in this case, let's take a look. It is given that for set A, okay, the elements of set A is single digit prime number, okay, and elements of set B, single digit even number. Okay, once again, I want to specify that this is positive. Okay, apologies for that. Set B, elements are single digit, positive, even number. Okay, now for part A, let's take a look. List all the elements of set A and set B in set notation. Now, I would like to recap, okay, the definition of prime first and foremost. Do you remember what are prime numbers? We haven't really done this in a while. Some of you may have forgotten, but what are prime numbers? How many factors do prime numbers have? How many factors do prime numbers have? Very good, Sherilyn, 2. And what are the two factors? 1 and itself. Okay. So what is the smallest prime number? I want to know so that I can start writing down my elements from smallest to biggest. What is the smallest? prime number? Is it 1? It's not 1, it's 2, okay? 1 is not a prime number, it's a special case, okay? It's neither prime nor composite. 0 is also not a prime number, special case once again, neither prime nor composite. Okay, so smallest prime number is indeed 2. Very good, Sherilyn and Perka. After that, we want to write down the subsequent prime numbers. We've got 3, 5, 7, and that's it. Because I only want single digit. The next one after that would be 11, but 11 is double digits. Okay, so there you go, we stop there. And then for B, single digit positive even number, we did this earlier, 2, 4, 6, and 8. Okay, now for part B, okay, let's take a look and answer this question. Are A and B equal sets? Explain your answer. I think it's quite straightforward. Okay, they do have some similar or sorry, actually identical terms. It's just 2 in this case. So pretty straightforward. They are not equal sets. So you can just say not equal or A does not equal to B. Okay, so let's explain. The reason is because they do not contain the exact same element. Okay, now even though NA is equal to NB, because in this case NA equals to 4, NB equals to 4. Okay, same number of elements. I need two conditions to be true. Exact same elements, first condition, and same number of elements, second condition. So in this case, only the second condition is true. But the first condition, having the exact same elements, is not true. So therefore, this is how you want to explain it. Okay? A is not equal to B because they do not contain the exact same elements. Very, very simple. Now let's move on to bubble question 3. So in this case, I've got set F and set G. Set F is an element, sorry, it's a set where the elements are both prime and composite number. And set G is an element which is a whole number, but not a positive integer. Now, which of the following statements is true? It sounds a bit confusing, but I want you to take some time to really think about it. Before we go into the question, prime number, again, only has 2 factors. Composite, it has more than 2 factors. So anything that can be divided by 1 itself and any other number is a composite number. So like 4, 10, they are composite numbers because 10 can be divided by 2, it can be divided by 5. Okay, now G, it's a whole number but not a positive integer. So it sounds confusing, but I want you to really think about it. Okay, which of the following statements is true? So once again, look at all the 4 options and then decide which one is true. Time starts now. You've got 1 minute, 10 bubbles if you get this correct. Let's go. Okay, so I know some of you are a little bit out of touch with the definitions of numbers, so that's why I'm giving you a heads up and reminding you what prime numbers mean and what composite numbers mean. Okay, but at the same time, you also want to think about what's the difference between a whole number and a positive integer. Okay, so in set notation, you want to be very, very sensitive to the definitions of your real numbers. What's a rational number? What's an irrational number? Okay, if you forget about it, if you have forgotten, then probably it's time to go back to your Sec1 textbook to recap on the definitions of these numbers. Okay, 10 seconds left. 7, 6, 5, 4, 3, 2, and 1. Oh no! Okay, so it looks like a lot of you didn't manage to get this question correct, but that's fine. Now I'm going to take some time to really explain, okay, how, or rather, how to determine which statement is true, okay? Because you want to go through the statements one by one, and some of them can be very tricky, okay? And we set a few traps in the options as well, so some of you fell into those traps. Now, let's take a look, okay? We want to actually start by listing the elements of each set. So set F, right? It is it contains elements that are both prime numbers and composite numbers. Now, does that actually exist? Is it possible for a number to be both prime and composite? What do you think? If a prime number has only two factors and a composite number has more than two factors, then there's a conflict. You can't have just two factors and more than two factors happening at the same time, right? So what kind of set is set F? What's the special name that we have learned for set F? If it's not possible for a number to be prime and composite, that means it has no elements. So a set with no elements is called what kind of set? Null set or empty set. Okay? So you want to present it like this. Okay? Or also, this is possible. It's a null set, it's an empty set. Okay? Now, let's look at G. Now, what number is a whole number but not a positive integer? So, let me ask you, a positive integer starts from which number? What is the smallest positive integer? An integer is a number with no decimal places. Okay, so what's the smallest positive integer? You start from anyone, come on. Definitions. This should come to you. Or if it doesn't, then time to recap and go back to definitions of numbers. No, Sarah, unfortunately, we don't start positive integers with zero. Okay, a zero is neither positive nor negative. So we actually start with one, followed by two, followed by three, and so on. Okay, but now let me ask you about whole numbers. Whole numbers, we start from what? What's considered a whole number? 1, 2, 3 are whole numbers, yes. Also no decimals, but we have to start from zero because actually zero is also a whole number. Okay, so this is just a definition thing, okay, which a lot of students often miss out. So I want to take this time to also to emphasize once again that whole numbers, you start from zero, followed by one, followed by two, and so on. And then for positive integers, you start from one, followed by two, followed by three, and so on. So the odd one out here is zero. Zero is indeed a whole number, but not a positive integer. So therefore, how do we write down the set? Okay, we write down the set, the curly braces with the zero inside. Okay, now this question appears really simple, but it's meant to trick you because some students will think that this and this are the same thing, but they are not. One of it is an empty set. One of it is a set that contains one element. So they are not equal. So already, first option is out. Okay. Now, third option is also out, and some of you actually, quite a number of you actually fell into this trap. More students chose option 3 compared to option 2, which is the correct one. Now, here, again, to remind you, it means null or empty set. But as I mentioned earlier, G is not an empty set. It's a set that contains one element and that element is zero. So you see why this can be confusing and why a lot of you actually fell into this trap. Okay, and then lastly, number of elements in set G is 2. This one is pretty straightforward. There's only one element in G, so this is also odd. So therefore, that's why option 2 is correct. Okay, and option 2 basically means that F is an empty set or a null set, and that's why it's correct. We've already established that. Okay, any questions, any confusions before I move on to start on the diagram? No? Are we good to go? Okay, let's move on. Okay, I'm going to show you actually an animation. Okay, and let's take some time to learn this new concept of Venn diagram. So we want to understand set notation using Venn diagram. So a set can actually be represented by a circle. Okay, so I've got a circle here that has the letter A to the side. So basically, this circle, okay, I'm going to shade instead. This circle represents set A. Okay, then I have a circle here to the right. Okay, and this circle here represents set B. So we have set notation, which we learned earlier, and set notation can also be translated into Venn diagrams, which is what you see here. And that's what I was talking about in the beginning when I say that this topic is very visual and there are a lot of diagrams. Then what about this peculiar symbol that we see here? It's a Greek symbol. I've actually forgot the word for it. I think it's epsilon, if I remember correctly. Epsilon. Okay, but it basically, you don't need to know that. It basically represents the universal set. So the universal set is actually the whole rectangle. Now, why do we need a universal set? Because some elements are in set A, some elements are in set B, and then some elements are outside of set A, set B. It's just hanging around here outside the two circles. Okay. Now, with that, I'm going to move on to another concept, which is complement of a set. What does this mean? Let's take a look. Now, using Venn diagrams to explain the concept of complement of a set, okay, over here, I shaded everything that is outside of the circle A, right? Outside of set A. So that's A complement. Now, if I do the same for set B, that's B complement. Okay? And then, okay, there you go. Just two parts. Okay, once again, let me play that very quickly. I want you to now focus on how it's represented. What symbols do we use to show A complement? Now, you see the apostrophe here. A complement. We use an apostrophe to represent complement. And here we have B complement. Okay, so there you go. So complement basically means I'm not interested in whatever is within the set. I'm interested in whatever is outside the set. Okay, now let's move on to a worked example and apply the concept of complement. Okay, part A. List all the elements of the universal set and of A and of set A in set notation. Okay, now universal set basically is elements that are odd numbers between 1 and 2 inclusive, and then multiples of 5. Okay, now let's take a look. I want to start with the universal set. So I will write down my epsilon symbol like that. Okay, followed by my curly braces. And odd number between 1 and 20 inclusive means it can include 1 and it can include 2. Okay, so 1 is indeed an odd number, followed by 3, 5, 7, 9, 11, 13. No, not 18, sorry, 15, 17, and 19. And I stop there because it stops at 20, right? It's between 1 and 20. But 20 is not an odd number, so I exclude it. Now, that's my universal set. I now want to actually write down my set A. And take note, for set A, you can only take numbers from the universal set. So all you need to do, right, is to actually, sorry, to find elements in set A, all you need to do is go through the elements in the universal set and see which one is a multiple of 5. 5, definitely. And then the next one is just 15, and that's it. So set A only has two elements, 5 and 15. Okay, so there you go. Now, part B. Okay, how do we draw a Venn diagram to represent these two sets, or rather just the universal set with set A? So, very, very simple. Okay, you want to start by drawing the rectangle. Oopsies. Okay, there you go. This is your universal set. and then followed by set A. Set A. Okay, so a circle with the letter to the left or to the right. Usually, when the set is drawn to the left, then we draw the letter to the left as well. If it's drawn to the right, we draw the letter to the right as well. Now, set A has how many elements? 2, 5, and 15. So I'm just going to draw them here, 5 and 15. Make sure they look distinct and not jumbled up like it's a single element. Okay? It needs to look like two distinct elements. If you need more space, draw the circle bigger. Now, after that, there are elements outside of set A, right? That's still in the universal set. So I'm just going to draw them within the rectangle, but make sure it's outside. But again, okay, make sure you draw them distinctly so that it does not look like the same element. And there you go. 1, 3, 7, 9, 11, 13, 17, and 19. Okay, so that's it. Yeah, that's how we draw a Venn diagram with a universal set and one set. Okay, set A. Now, with that, let's move on. Okay, there's part C and part D. So over here, I have the exact Venn diagram that I've drawn. Okay, it looks a lot nicer. Part C, let's answer some questions related to complements of a set. So part C is asking us to list all the elements of a complement in set notation. So as I've mentioned earlier, a complement is everything outside of set A. So you shade literally everything except for the circle. Now, can you take some time to write down the elements in set A prime? Okay, another thing that I forgot to mention earlier, this is A complement, right? Some people may read this as A prime. The apostrophe can be read as prime. But it means the same thing. It means we are looking outside. We are looking at complement of the set A. Okay, so part C, when we list the elements, we write down A complement equals to, again, curly brackets, and then we list down all the elements 1, 3, 7, 9, 11, 30, and 17. So there you go. Okay. Denise asked me, for the elements in set A, does this also apply if the notation for the first set change in its handwriting like capital E instead of cursive? Does this also apply if the notation for the first set change its handwriting? Denise, I don't quite understand your question. But for universal set, we still want you want to write down as the cursive E and not like a normal E. Okay, it's kind of two different things. So take note. Okay. But yeah, let me look at part D. If I didn't quite answer your question, maybe you can ask me again at the end of the lesson. Okay. Now, part D, I'm just interested in finding the number of elements first in the universal set, number of elements in A, and then number of elements in A prime or A complement. So universal set is just everything. So 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So I've got 10. 10 elements in total in the universal set. In set A, very simple, just 5 and 15, so it's 2 elements. So in A complement, you actually don't need to count. You can just take universal set, number of elements is 10, minus set A, number of elements is 2, so you should be left with 8. But if you do count 1, 3, 7, 9, 11, 13, 17, that's 8 elements in total. Okay? Now, bubble question 4. Awesome. Okay, so we've got how many questions? Once again, 6. No, 3. I have 3 questions coming up back to back. Okay, and that's actually going to be the end of our lesson. So let's get through the last 3 questions. Okay, starting off with bubble question 4. Now over here we've got a universal set where x is an even number between 20 and 39 inclusive. Take note of the word inclusive. Once again, inclusive means this number and this number is included. Okay, it can be considered. For set A, it is elements that are multiples of 4. So you only need to look at the universal set. Okay, take note, they didn't describe a range for set A. That's because you just need to look at the elements in the universal set. So make sure you write down the elements in the universal set correctly, because if your universal set is wrong, then your set A can also be wrong. Okay, so just write down and choose the option which gives you the correct that represents A in set notation correctly. Okay, 1 minute for this. Your time starts now. Okay, if you have a piece of paper with you, make sure you take some time to write down the set notation properly. Okay, because you're going to need that. Okay, just giving you a heads up, you are going to need that for bubble question 5 and bubble question 6. Okay, let's go. Now you've got 30 seconds left. Half the time has passed. So let's go ahead. And so far, about three quarters of you have answered. Still a handful of you left. Take note of the clock, 20 seconds left, and I hope to see everyone answering. Once again, so far only bubble question 2 had full participation for this lesson. 10 seconds left. Now, 5, 4, 3, 2, 1. Okay? So, as I mentioned, okay, if we are given universal set, always start by writing out the elements in the universal set. 20 and 39 inclusive means we can consider them. So let's start with 20. Is it an even number? Indeed. So after that, you just list out all the subsequent even numbers. Make sure you don't list anything out. 22, 24, 26, 28, 30, 32, 34, 36, and 38. We stop there because the next even number is 40. 40 is outside of the range. Okay, so even numbers, once again, it means that it has to be divisible by 2. Now, the condition here is that it must be multiple of 4. So as I've mentioned, you need to look at your universal set and see whether that number or that element is divisible by 4. So let's start with 20. Is it divisible by 4? Yes, indeed. And 24 is divisible by 4. 28 is divisible by 4. 32, 36, and stop there. Okay? So you start to see a pattern almost. It's like you are just taking every alternate number. But take note, you might not always see this pattern. It depends on the question. Okay? So let's write down the elements of set A: 20, 24, 28, 32, and 36. So there you go. I want elements of set A, so that would be option 3. Okay. Now let's move on. Bubble question 5. Which of the following elements represents the Venn diagram for set, universal set, and set A in set notation? Okay. Now to give you a bit of help, I'll write down the sets here. I mean the elements in set notation here. So this is set A. And then for set B, you have 20, 22, 24, 26, 28, 30, 32, 34, 36, 30. Okay? Now, 1 minute and 30 seconds for this. Time starts now. Take your time, look through each option carefully, and because there are a lot of numbers, you don't want to miss anything out. Okay? Plenty of time, 1 minute and 20 seconds left. Okay, don't rush through this. Just choose the correct set where it represents this universal set and set A correctly. Okay, 1 minute left. So far, everyone is getting this correct. Great job. Okay, 45 seconds left. Okay, 30 seconds left. 25. I've got two more students. Come on. Last two to choose your options. 15. Now, 10, 9, 8, 7, 6, 5, 4. Alright. So, just a show of hands, when you were choosing the correct set, right, which one did you look at first? Do you look at the universal set or do you look at the set at set A? Anyone? Now, it's a lot more straightforward if you actually look at set A first because it only has five elements. So just take a look quickly at set A. Which one doesn't have five elements? Option 1 and option 3. So these two are immediately off, cancel. Now let's take a look at option 2 and option 4. So in this case, let's take a look at the remaining numbers. So 22, 26, 30, 34, 38. Correct. 20. Oh, then there's something else that's wrong. It's the elements in set A. It should be 20, 24, 28, 32, 36. It's very subtle. So 20, 24, 22, 28. Sorry. 20, 24, 28, 32, 36. Okay, so this one's correct. And then over here, we are actually missing a 20. Okay, there is 24, 32, 28, 36. Oh, there's only 4. Yeah, so this should be off as well. So the correct option is option 2. Okay, let's just double check that all the terms outside are correct. Complement of A, 22, 26, 30, 34, and 38. Indeed, they are correct. Okay, now let's move on to our last question of the day. Okay, it's 8:54 p.m., so I believe we're going to actually end pretty early, but take a look. Bubble question 6. Which of the following represents a complement in set notation? I hope you drew your set earlier, okay, because you're gonna need it, okay? If you didn't, okay, I'll just spend 1 minute drawing the set very quickly. Okay, set A has 5 elements, and that's 20, 24, 28, 32, 36. And then outside of set A, we have 22, 26, 30, 34, and 38. Okay? If you didn't draw your own Venn diagram, then I've got this to help you out. So which of the following represents a complement in set notation? 1 minute, your time starts now. This is 10 bubbles. With the diagram that I've provided you, this should be very, very easy. And I hope none of you get this wrong. All right. 15 seconds have passed, 45 seconds left. Okay, pretty good work so far. I have two students making a mistake. Majority of you are getting it correct. But those of you that made a mistake, I want you to take a look and see whether you can spot your own mistake. Okay? 10 seconds left. 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now, a complement, as we have learned earlier, right? If you remember the animation, we want to actually shade everything that is outside of A. Okay? So everything in the universal set, but it must not be inside of A. Okay? So there you go. Once you actually shade that, it becomes really, really, really straightforward. Make sure your A complement has 22, 26, 30, 34, and 38 in it. The first one is out because there's 39 in it. The third one is out because it's missing a number. There's five elements in A complement. This one only has four. And second one, we have too many. We have 1, 2, 3, 4, 5, 6 elements. The correct one is option 4, and indeed it has 22, 26, 30, 34, and 38. Now, with that, we have wrapped up today's class. I'd like to show you before we end a try it yourself question. You can attempt this question. You can take a screenshot. Otherwise, you can actually look out for the announcement in your Genie Ask chats on how you can attempt this question. Four parts and it's worth 40 bubbles. Okay, wish you all the best. And quote of the day: if you want to learn a new language, you must understand its basic notation and alphabets. So studying sets is like studying a mathematical language, so understanding its basic notation is key. But I think that for today's lesson, it was pretty easy to follow, pretty easy to understand. Next week's lesson onwards, once we start to learn more about Venn diagrams and how to find intersection and union of sets. Okay, two new concepts that we're going to be focusing on quite a lot next week. Questions will start to get more and more interesting. Okay, now again, these are things that we have learned. Okay, element of a set is not an element of a set, and number of elements in a set, as well as equal sets, empty set, universal set, and complement of a set. Okay, I'll end off with a quick question and answer segment. If you do have any questions, please feel free to stay behind, and I'll stick around for a bit to answer your questions. Okay. If not, I'll see you guys around. Okay, please say hi to Teacher Kim for me next week when you see her. And take care. Enjoy the rest of your December holidays. Bye bye.